The ESA Horizon 2000 program and the Cosmic Vision program, with its cornerstone missions and its smaller, medium-sized missions, has really paved the way for a completely new astronomy in the last decades. And that has been done together with NASA, with their great observatories. And so ESA has roamed the solar system. We have made some firsts by landing on Titan and landing on a comet. We have studied the universe in all different wavelengths. We have developed leadership in the cosmic microwave background studies, and in particular in astrometry studies. In all these endeavors, international cooperation is a very important element, and the European Space Agency is the partner of choice for almost all spacefaring nations around the world. Traditionally, astronomy has been done from the ground, from mountains, but space has actually opened completely new windows. There are some wave bands which are just not observable from ground, like gamma rays and X-rays. They don't penetrate to Earth, fortunately. But space is also important. For a long time, it provided the best image quality with the Hubble Space Telescope. In the meantime, I think big ground-based observatories are able, with adaptive optics, to develop similar image sharpness. But space still has one huge advantage, that is the stability. If you are dependent on extreme high precision stability, like for instance with Gaia or with the exoplanet missions, space is the only possibilities. And again, you need to operate a fleet of observational capabilities in many different wavebands and with different technologies, and that is done in international cooperation. The long-term strategic planning of the science missions also requires a long development of technology in preparation for these missions. One example is the Smart 1 that has developed solar electric propulsion, which is now used for Bepi Colombo to go to Mercury, and will hopefully be employed in many other solar system missions in the future. We are preparing a whole fleet of exoplanet missions, which are deriving their technology from previous observatories. And another interesting example is also LISA Pathfinder, which has developed the drag-free gravity measurement system, which is essential for LISA in order to discover gravitational waves. And then also, for instance, for Athena in the X-ray mirror technology, we are basing our experience on many decades with XMM Newton and previous X-ray telescopes, but now we also employ robotic assembly activities. And so the technology development is a crucial element in order to enable the long-term vision. And another crucial element is an early cooperation with our international partners so that these visions are synchronized and co-aligned. Looking back at our achievements in the last year, my top priority is Gaia, because that has completely changed our understanding of astronomy, and it has published about 800 publications, about 2 to 3 papers every day. And one of the most exciting, fascinating elements is that it is able to decompose the archaeological history of our galaxy. And I was in particular excited about a paper about a merger of our Milky Way with another galaxy about 10 billion years ago, which has likely produced the thick disk and the bulge and maybe even the black hole in the center. So Gaia is really the top hit. We also get very exciting results, for instance, from XMM Newton about the missing matter in the universe. There was a riddle that about 25% of our known and loved matter is missing. And XMM Newton has discovered that in a very hot, warm, hot, and very feeble component of the intergalactic gas between the galaxies. And that was a major breakthrough too. More excitement on Mars, where Mars Express has discovered liquid water under the South Pole. And the ExoMars Trace Gas Orbiter is writing a detective story about trace gases on the planet. And then my pet project and pet object is Oumuamua, the interstellar visitor. that has been discovered already 1 year before when I was still in Hawaii. But now Hubble Space Telescope has discovered that the object is actually accelerating away from the solar system. And this has caused a lot of speculations about the nature of this object, which is still keeping us busy.